Hi, I'm Kumaran. Today we are going to look at the runtime complexity analysis of merge sort. The prerequisites for understanding this video are prior knowledge of big O and theta notations, also an understanding of merge sort algorithm. Just to give you a recap of the merge sort algorithm, merge sort is a divide and conquer based approach and it distinctively consists of 3 steps. The first step is dividing the array into 2 equal halves. The second step is calling the merge sort on each of the 2 halves recursively. And the third step is to merge the 2 sorted halves returned by the step 2. Let's see how much time each of these steps take. The first step is merely finding the midpoint of the array, which is an arithmetic operation, and we can assign it a constant time, let's say C1. For the second step, let's assume that T of n is the time taken to merge sort n elements. So T of n by 2 will be the time taken to merge sort n by 2 elements. In our second step, we are going to have 2 equal halves of size n by 2 each. So the total time taken for this step 2 is going to be 2 times T of n by 2. Now for the third step, the time taken to merge 2 sorted arrays of size n and m is going to be of the order of n plus m. Let's see how this is with the help of an example. Consider 2 arrays, one array 1, 5, 10 and the next array is 2, 7. Typically an algorithm for merging 2 sorted arrays is going to look like this. So you would have 2 pointers p and q pointing to the start elements of the array. You compare the 2 pointers, whichever is smaller, put it in a resultant array and increment the pointer. Again compare the 2 pointers, whichever is smaller, put it in the resultant array and increment the pointer. You keep continuing like this until either p or q meets the end of the array, and once the end of the array is met, you copy the remaining elements from the other array into the resultant array. So essentially we are looking at each and every element in both the arrays, and that's why I said it's going to be of the order of n plus m. In our case in merge sort, both these arrays are of the same size, n by 2 and n by 2, so the time taken is going to be of the order of n. To be more precise, let's give a constant time C2 for all the other operations in this merging algorithm, such as iteration and comparison operation. So the definite time taken by this step is going to be C2 times n. So the total time taken to merge sort n elements is going to be T of n is equal to the summation of the time taken by each of these steps, which will be C1 plus twice T of n by 2 plus C2 into n. Here, C1 and C2 being constants do not predominantly affect the growth of the function Tn for relatively large values of n. So we can say that T of n is almost equal to twice T of n by 2 plus n. One more thing to be noted in case of the merge sort is to sort an array of just a single element, it's going to take a unit time because an array of single element is sorted by itself. So T of 1 equals to 1 is going to be the base case for this recursive equation. Now we can expand T of n by 2 as, again using the same recursive formula, as T of n by 2 is equal to twice T of n by 4 plus n by 2. Substituting 2 into 1, you have T of n equals to 4 times T of n by 4 plus 2n. Now expanding recursively T of n by 4, we would be getting something like 8 times T of n by 8 plus 3n. To write this in a more generic way, we can say T of n is equal to 2 power k T of n by 2 power k plus k into n. Here we can keep on recursively expanding T of n by 2 power k until n by 2 power k becomes equal to 1, or in other words, n is equal to 2 power k or k is equal to log to the base to n. Substituting these two into this equation, you have T of n is equal to n into T of 1 plus log to the base to n into n. T of 1 is equal to 1, we know that from our recursive base condition, so n plus n into log to the base to n. So this is going to be the final value of the time taken to merge sort n elements. It consists of 2 components, n and n log n. N log n being the higher order term will be increasing asymptotically at a faster rate, and hence we can say that the complexity of merge sort is of the order of n log n. Thank you.